This is chapter 2.5, and the question says a certain brand of automobile tires has a mean lifespan of 35,000 miles and a standard deviation of 2,250 miles. Assume the lifespans of the tires have a bell-shaped distribution. So you know you're talking about empirical rule when you know it's bell-shaped. And here are the three tires, 34,000, 37,000, 31,000. That's what the lifespan of that tire is. And we want to find the z-score to find out if any of them are unusual. Now remember, z-scores are considered unusual if they're not in between -2 and +2. Then we have a second set of tires that have different mileages for their lifespans, and we're supposed to use the empirical rule to find the percentile. And I'm going to show you that in just a minute. So first we're going to do z-score, and here's the formula for z-score. It's x minus mu, and we know that the x was the lifespan of the tire, 34,000, and the mean, which we know was 35,000, is mu, and the standard deviation is theta. So that's 2,250. You'll take that and divide it, and you get a negative 0.44 as your z-score. Now that one is usual because it's in between -2 and +2. So now we're going to look at the next tire. The next tire had a lifespan of 37,000, and there's your z-score formula again. And so here's the length of the lifespan of the tire minus the mean divided by the standard deviation, and the z-score is 0.89, which is also a usual z-score. So both of these tires are considered usual, so you'd want to buy one of those. Next, we're going to look at one that is unusual. It comes out to be -2.22. This was a 30,000 mile tire, so we subtract the mean from that and divide by the standard deviation, and that tire is unusual. So we look at the z-scores that are between -2 and 2 to say that the z-score is usual, and I know that that z-score is not usual, so that tire has an unusually short lifespan. The next part of the problem, you had to do the same thing. You find the z-score, but you're going to find the percentile, and I'm going to show you how you get this using the empirical rule in just a minute. So the first thing you need to do is find the z-score of each one of these. This z-score is 1, and the other z-score is 0. So, and here I've got something right here that I don't need. I'm going to take it and just slide it up here so it's out of my way. Well, I thought I was, but I didn't. Oh, I can't get rid of it. Hold on a minute. Okay, now it's out of my way. And so what you're going to do is you have a z-score of 0, 1, and -2, and I'm going to show you where you get these percentiles by looking at the empirical rule. So let's take a look here at the empirical rule. The empirical rule is always going to be a bell-shaped curve, and in the middle this is your 50th percentile. And there's 34% that's one standard deviation on this side of the mean, and 34% that's one standard deviation on this side of the mean. Those two add up to 68%, 34 plus 34, and this one's one standard deviation above the mean, this one is one standard deviation below the mean. And then from there you have another 13.5% here and a 13.5% here. So this means that I have 47.5% that is two standard deviations below the mean, and 47.5% that's two standard deviations above the mean, and so on, and you'll see the numbers here as it goes down. I'm running out of time, so I'm kind of hurrying with this, but anyway, for -2, two standard deviations below would be 0.15 plus 2.35, which is here. If I want to go to one standard deviation, a positive one, that's here, so I add up everything that's below that one, and that's those numbers. And then I want to go to the 50th percentile, which is here, and I add up the four numbers that are below the 50th percentile.